Hi. Let me talk about OOPS concept today in Java and give examples in Java. Actually, OOPS with Java. It's the OOPS concept can be completely abstracted. Right? So OOPS with Java, object-oriented programming system. So uh, let's talk about the terms within OOPS. Like we have something called as classes. Now, what exactly are classes, right? Classes are like is kind of a template that tells the structure and the behavior of an object. One second. Tells the structure and behavior of an object, right? I mean, if you have worked on Java or any object-oriented class language, you would know what a class is. So, for example, you create a class, say XYZ, and then you have member variables, then you have behavior, which is the methods within that class. So you have multiple. I mean, that's a class. Then you have something called as an object. So basically, if you're taking the abstract or OOPS, which is not related to any particular language or implementation, object will come before a class, right? So class, you actually you first define what an object is, right? According to your need. So, for example, in something called as a class or a house, you have different household objects like a TV, like a fridge, a sofa, and stuff like that. So first you define the objects, then you take these objects which you want, which are required, and then create a class out of it. So basically, what are objects? If you take in the reverse, objects are the instance of a class, right? So if you have class XYZ, you create new XYZ within brackets, new XYZ and then brackets, and then you assign it to a reference of a particular class, right? And then becomes that is your object, right? So object is an instance of a particular class. So it has its own state and its own behavior, right? And behavior. Then you come to something called as encapsulation. Encapsulation is basically hiding internal data and methods within a class. You hide the internal data and methods and only expose those which are necessary for the rest of the program or rest of the our clients or further down whoever is using that particular object or a class. It does not require whoever is using it does not require all the details. Some things need to be hidden, right? Some things need to be private. Something needs to be public. So encapsulation allows you tells you that something should be private and something should be public. Even the state as well as the behavior. So methods as well as variables can be private as well as public. Now the reason why you require private variables is because I mean there is some housekeeping to be done within the particular object, or certain state needs to be maintained which need not be made public to the users of this particular object or class, right? Some things housekeeping or some things are state as well as some calculations in between calculations. All this can be stored in private variables, and the same thing in methods, right? Certain methods like again the same thing, house cleaning or things which do not require to be output or being used by the other public methods, right? You have multiple private methods which are being called by a public method, right? These are all internal, need not be actually shown to the users of this particular class. So encapsulation allows you to do it, and you can do that in Java using private and public modifiers. Right. Then we have something called as inheritance. Right. Inheritance basically allows one class to inherit the properties and methods of another class. Right. So, for example, you have something called as let's you say you have something called as animal class, right? Now, animal class differentiated from a bird class, differentiated from a say fish class, right? So animals have certain properties which are different from birds, they're different from fishes and insects and stuff like that. So you define a class called animal, but then you have a specific type of animal called mammals, right? The mammals are also animals, right? Mammals are not birds, mammals are not insects, right? Mammals are specific types of animals, right? So they have most of the properties of animals, right? But they have their own specific extra properties or properties which are not there in most animals, right? Like mammals don't lay eggs, right? Mammals give birth, right? So mammals usually are cold-blooded, right, or warm-blooded, sorry, right, and stuff and other things which are specific to mammals, right? Then you have something called a human, which is a mammal, which is also an animal, right? So you have a hierarchy, which is animal, then you have mammal, then you have human, right? This is particular hierarchy of classes. So that's called inheritance. So human inherits from mammal, mammal inherits from animal. So this is called as inheritance, right? Then you have something called as polymorphism. Polymorphism allows objects of different classes to be treated as objects of a common superclass. This is actually more an implementation detail, right? See, you have a reference of animal, but you can pass an object of human to that animal, to that reference of animal. Always allowed, right? Somewhere in the subclass can always be passed to object of subclass can always be passed as to a reference of the superclass. Now, so basically, you have this, you have the animal, you have a human, and but it's in the reference of an animal, right? The reference is a type of animal, but you pass the object of a human to it. Now you can use this animal across different reference animal across different parts of your program, because the other these parts are not required to know exactly is it the animal a human, is it a mammal, or is it an elephant, right? You don't need you do not need to know. So it creates kind of a flexibility, right? If I don't need the extra information, I don't need to use it. So I can pass some later on. I can pass instead of human, I can pass say a giraffe, right, or zebra, whatever. I can pass that, and it will still work. It will not. You need to modify it. So that's called just an implementation related polymorphism. So basically, what it says, it allows objects of different classes to be treated as objects of a common superclass, right, with the same reference. Then you have something called as an abstraction. Where abstraction is kind of the basic of OOPS, right? Basically, what you're doing is that you take all the details of a particular object, right, and you abstract only, you take only the details which you require, right? Some things can be actually treated differently depending on what you require. Like, for example, if you say household objects, right? If you don't want the details of the household object, you can just club that all these objects, as I mentioned, TV, fridge, sofa, fan, stuff like that. All you can club into one class called household object, right? You're abstracting. You're actually you're focusing on essential features and hiding unnecessary details. You you This household object can just have two variables, right? Maybe location, where the location is in the particular house, is it in the kitchen or in bedroom, something like that, or and the name of the object, name of the object, like is it a fan, is it a fan, TV, stuff like that. I don't need to know how fast the fan is moving, right? Program does not need to know. Program needs to know is what is the name of the object and what is the location of the object, right? So we are abstracting, focusing on essential details and hiding unnecessary details. But uh, see, you can also abstract it by information hiding, right? It's the same thing, right? I mean, you're hiding information hiding. You do not say, for example, uh, again, a fan, right? Now I need to know this. I mean, I don't need to know the speed of the fan. I just need to know it's moving or not. But somewhere else, I might need to know the speed to calculate. Say if it's on or off. I need to know is the fan moving, right? So speed. Supposing it's zero speed, it's not moving. If it's more than zero speed, it's moving. So I'm storing the zero speed in a variable, and that variable is say speed, and I'm making it as private. Now if I make it as private and speed, so then what happens is that the I'm actually doing abstraction. I'm actually hiding the details, right? It's called abstraction. So information hiding also creates NCAPS abstraction. But then you also have polymorphism, which also creates this it creates the illusion of abstraction. Because since I'm passing, say for example, I'm passing animal right to the animal reference, but I'm having human as the object to that reference. The instance actually is human, but the reference is animal. I'm actually hiding the details that that particular reference is actually human. It's unnecessary. So for the rest of the program, or where I'm going to use that particular reference, right? So that's also called abstraction. Different ways of or multiple ways which you can realize abstraction. Then you have something called as association. Now, these are association are things between different classes, right? It's a relationship between one or more classes, relation of two or more classes. Now, there are different types of association. One is simple association. Simple association represents a relationship between two or more objects where they're connected but not dependent on each other. So it basically uses a relationship. For example, a driver or you say the car and its label, right? Supposing you supposing it's in a race course, right? The cars are racing. You see the labels on those cars, right? Those are actually advertisements, logos of company stuff like that. Obviously, you can remove those labels, and I mean it's a kind of weak kind of relation between two classes. A car and a label, right? It's a kind of weak relationship. The car will have an instance of that particular label, right? But then you can always change the label easily. Just remove the label and the label is, I mean, you can replace it with another label, right? So it's kind of weak kind of relationship. Then there's a stronger relationship that's called a simple association. Then you have some stronger relationship called aggregation. Now, aggregation is represented the whole part of relationship between objects, implies has a relationship. So, so its object is composed of other objects. For example, you have a car, right? A car has a driving steering wheel, has has wheels, four wheels, right? It has a horn, it has lights, right? Stuff. So now, obviously, if you go to repair shop, you can replace these tires, you can replace these steering wheel and all this stuff. So but it is still stronger relationship. It feels like a stronger relationship than a label to a car, right? Of a race car. It's a strong relationship. It's engine, right? It's a stronger relationship than a label, right? So that is called as an aggregation, right? But the tires can exist without the car, right? You can sell it in second hand. You can always the steering wheel once it's removed can be repaired and given to some other second hand car. Right? So it's not it's stronger relationship than a simple association, but not very strong. I mean, these all the component objects of the container can live separately. I mean, live independently. Then you have something called as composition. Now, composition basically means it's a very strong form of aggregation, which the lifetime of the contained object is controlled by the container. So basically, it owns. So if you remove that component from the container, the component no longer exists. I mean, it has no reason to exist. Right? It can be garbage collected. For example, a person and his address. Right? Supposing you created a new instance of address and you gave the street and say city and flat number and stuff like that, and then you give it to a person, right? Person has an address, but what happens if the person changes the address, right? You replace it with a new address. What happens to the old address? It's no longer required, right? It's no longer required. It can just be garbage collected. So person, I mean, it's not exactly owns it. I mean, the very very strong relationship. If the component object does not need not exist after the main object, it can be garbage collected. It can just vanish, right? It's the association between person and his address is a strong. It's called composition, right? So these are the different uh, explanations about. I mean, these are different OOPS concepts. I hope you understood. Thanks. Bye.